Hello everyone. Today we will be discussing power factor. But first, what if I told you that not all the power supplied to an electrical device is actually used to perform useful work? This happens because in AC circuits, voltage and current are not always perfectly aligned. When they become out of phase, some of the supplied electrical power does not perform useful work. This is why engineers use power factor to measure how efficiently power is being used. Power factor is defined as the ratio of real power to apparent power in an AC circuit. Real power is the power that actually performs useful work. Reactive power represents energy that oscillates between the source and reactive components like inductors. Apparent power is the total power supplied to the circuit, and it combines both real and reactive power. These three components form the power triangle. Power factor is also equal to the cosine of the phase angle between voltage and current. In AC circuits with inductive loads such as motors, the current lags behind the voltage. As the phase difference increases, the power factor decreases, meaning the electrical system becomes less efficient. Due to this decrease in power factor, there are several problems in electrical systems. First, it increases the current required to deliver the same amount of useful power. This higher current leads to greater energy losses in transmission lines and electrical equipment. As a result, the overall efficiency of the system decreases. To solve the problems caused by low power factor, engineers use a technique called power factor correction. One of the most common methods is adding capacitor banks to the electrical system. These capacitors help reduce reactive power and bring the voltage and current closer in phase, which improves the power factor and increases system efficiency. Power factor can be classified into three types: lagging, leading, and unity. Lagging power factor occurs in inductive loads such as motors, where current lags behind voltage. Leading power factor occurs in capacitive circuits where current leads the voltage. The ideal condition is unity power factor, where voltage and current are perfectly in phase. Let's look at a simple example. Suppose an electrical system uses 300 watts of real power, while the apparent power supplied is 500 volt amperes. The power factor can be calculated by dividing real power by apparent power. In this case, the power factor is 0.6, meaning only 60% of the supplied power is doing useful work. To summarize, power factor measures how efficiently electrical power is used in an AC system. A low power factor can cause higher current, energy losses, and reduced efficiency. By using techniques such as power factor correction, electrical systems can operate more efficiently and reliably.